Good morning, my name is Farid Litat. I am a technical specialist within GTT team. So today we are going to talk about how to create the step-skew geometry and how to optimize the mesh. So first we need simple 2D geometry, simple Flux 2D geometry. Then we import this Flux 2D project in Flux 3D, as you can see in the standard context. We enter inside the modeler in order to extrude 2 times. So first we extrude the rotor and then we extrude the stator. So we will have 2 objects. So the first layer will be 20 millimeters length. Okay. Same thing for the rotor. We select all the faces, including the layer of the air gap, and we will extrude it in the same length. So once it's finished, we are going to duplicate linearly 3 times the stator layer and the rotor layer with a 20 millimeter depth. Okay. Once we did that, we are going to rotate each layer of the rotor in order to make a step skew. So here we are going to rotate by one angle, one slot angle, and then we select one by one each layer and we rotate it by this angle. Okay, once we finish the rotation, we are going to cut the 3 layers. So we have to define a reference plan and then make a cut according to this reference plan we created. Once we have the separation of the object, the small object, we are going to move them by 360 degrees minus 45 degrees. So we are going to make rotation here. And now we have all the step skew defined. What I am going to do now is to create a cylinder, a portion of the cylinder surrounding the rotor in order to make an assembly and have one object to ease the cut later. So here I want to save first the project. Okay. So this is the cylinder. I will center the cylinder to surround the rotor. So I am measuring the diameter or the radius enter the sliding cylinder of the rotor. And I'm going to use a height of 100 millimeter and center the cylinder around the rotor. Then I will cut the cylinder according to the reference plan corresponding to the portion I want to study. Then I am going to make assembly between this cylinder portion and all the layers of the rotor. So for sure, obviously we need to unselect the portion of the rotor to avoid this error message, the assembly selection. Now I have the object corresponding to the rotor and the object corresponding to each layer of the stator. I want now to create a reference plane to 1 millimeter below the junction plane of two layers and 1 millimeter on the top of this junction plane between two layers. So then I will do this for all the layers. I will create a reference plane. Why I am doing that is to cut according to this reference plane. So later on I will have intermediate layers I will mesh with extrusive mesh, and then in the junction layer it will be tetra mesh, and like this I can optimize as I want the mesh, and I will not have any issue to make a mapping between the extrusive mesh and the tetra mesh. So once I created the reference plane, I can cut accordingly each layer, and then you will see afterward I will have several layers, a junction layer between the step skew layers that I will mesh in tetra, and then the intermediate layer will be meshed in extrusive mesh. As you can see, each time I make an operation inside the flags, there is a recording of the Python command. All these Python commands, later I will save them in a Python file that I can reuse as I want later. Okay, now I will finish soon the cut of all the layers. Okay, now I have a really visible junction layer that I am going to mesh in tetra, and the intermediate layer that I am going to mesh in extrusive mesh. So to do that, I need first to make an assembly in order to avoid some intersection. So I create again a big cylinder surrounding all the rotor and the stator. I will cut the cylinder to have one portion, and then I will make later an assembly between this surrounding portion and the other parts of the stator and the rotor. Okay, now I save the project. I will make the assembly. So I make the assembly between this big portion and all the other portion resulting from the different cuts I did. Now I leave the modeler to the standard environment and check the geometry. The geometry is correct. I save again the project, and I will select all the Python command, and I will create a new Python command file to save all these Python commands. Okay. Let's go now to the mesh, since the geometry is correct. I'm going first to measure the length of each layer. I want to mesh in extrusive mesh. Then I will create first a transformation corresponding to the length of. Okay, then we create the other transformation. After that, we are going to create the mesh generator extrusion corresponding to each transformation. Okay, once we created them, we are going to assign them to the volumes. I am going to make invisible these faces to access to the planes and make a selection by relation of the volume. So I select the volumes of a given plan and then the volumes of the other plan and make intersection, and I can select all the volume of the layer in one time, and I can assign them the corresponding mesh generator extrusion I created. I go here faster because it's exactly the same process. I use the selection by relation in order to make select the volumes I want for each layer. Okay, then once we created this, once we assign this volume extrusion mesh generator to the volume selected, we can now create a mesh line and assign it. It's enough to assign it on one line of each layer. Here we created the mesh line of 2 elements arithmetic, so we can see that it creates only 2 elements. But in the first layer, actually there is an issue. So I am going to create another transformation, a negative transformation, so we have extrusion from the top to the bottom, and then we can improve this mesh. As you can see, it's extruded in negative direction, in negative Z axis, and I create this mesh generator, and once again I am going to make a selection by relation of the volumes of this layer and assign the new mesh generator extrusion in negative direction. The other things we can see here is that my previous volumes are not centered on 0 or centered on X, Y. Then I go to the modeler and make simply a linear displacement by 50 millimeters in negative direction to center them, and then I can create the infinite box perfectly centered around the geometry. Make complete infinite box mandatory in order to make a link mesh between the two parts of the periodicity. Then I can mesh again, and I can see that finally the mesh line I gave is not respected. This is due to the fact I moved the geometry. Now I can simply reassign the mesh line information on given lines of the layers. It's enough, and all the lines on this direction, on this geometric or mesh generator will have the same information. Here, as you can see, I moved from 3 elements to 2 elements, but I will modify again the mesh line information on the layer on the border to use a geometric variation instead of the arithmetic one. So then I can mesh, and as you can see, on the top is good, but in the bottom it's not good enough. I will reorient to the mesh again, And now when I reorient the mesh, you can see that the geometric mesh is very good assigned. And now I can see that the borders are very well meshed, and I can keep 2 layers inside for the extrusive mesh in the central layer. And as you can see also, the junction between the step skew layers are very well meshed. I want here to hide the volumes in order to access to the view of the mesh of the magnet. If you remember, with the magnet, there is an air gap between the magnet and the lamination. That's why we have this kind of mesh. And as you can see, this is a very good mesh now, and a very optimized mesh. One trick here is to mesh faces first, or mesh line and mesh faces, because it's faster. Once you are happy with the mesh, then you can mesh the volumes like I did. Here we have the check mesh, and we can see the statistics on the mesh we did. That's all. Thank you very much.